Hi everyone, today we'll be learning about proving trigonometric identities. So we will solve these three identities on the board. So first, let's start with 1 over secant x plus tangent x plus 1 over secant x minus tangent x equal to 2 secant x. The first step would be making our denominators the same so that we can add these two values. So we can get that by multiplying the two denominators. So that secant x plus tangent x times secant x minus tangent x. And now we have to work on the numerator. For the first one, since secant x plus tangent x will be cancelled, we will have secant x minus tangent x left on our fraction. On the other hand, for the second one, since secant x minus tangent x is cancelled, we will have secant x plus tangent x left. Here we can simplify it by zeroing out tangent x minus tangent x, so that becomes secant x plus secant x, which is 2 secant x. And then for the denominator, we can use FOIL, so that secant squared x plus secant x tangent x minus secant x tangent x minus tangent squared x. Here we can zero out secant x tangent x minus secant x tangent x, so that becomes 2 secant x over secant squared x minus tangent squared x. So remember that we have a Pythagorean theorem identity, which says that tangent squared x plus 1 is equal to secant squared x. Here we can simplify it further by subtracting tangent squared x to both sides of the equation. Then that will give us 1 equal to secant squared x minus tangent squared x. So we can substitute 1 on our equation, so that becomes 2 secant x over 1, or simply 2 secant x. Now let's work on the second one. So the second one is 1 over cosine x plus 1 plus 1 over cosine x minus 1, and we have to prove that it is equal to negative 2 cotangent x cosecant x. First, what we have to do is make the denominator equal so we can proceed with adding these two fractions. So let's multiply cosine x plus 1 and cosine x minus 1. For the first fraction, since cosine x plus 1 will be cancelled, we will have cosine x minus 1 as the numerator. For the second one, since cosine x minus 1 will be cancelled, we will have cosine x plus 1 on the numerator. We can zero out negative 1 and 1 here, and then we'll have cosine x plus cosine x, and that's 2 cosine x. For the denominator, we can use FOIL, and we can get cosine squared x minus 1. So this leaves us with 2 cosine x over cosine squared x minus 1. So from the Pythagorean identity, sine squared x plus cosine squared x equal to 1, we can say that if we transfer 1 to the left side of the equation, and if we transfer sine to the right side of the equation, that will mean that cosine squared x minus 1 is equal to negative sine squared x. So we can replace that on our equation, and we will have 2 cosine x over negative sine 2x. Negative sine squared x rather. So that becomes negative 2, and then we factor out sine. That's 1 over sine x and 1 cosine x over sine x. We know that 1 over sine x is cosecant x because of the reciprocal identity, and then we also know that cosine x over sine x is cotangent x because of the quotient identity. So that will give us negative 2 cosecant x cotangent x. Okay, so now let's work on the last problem, which is 1 over 1 minus sine x minus 1 over 1 plus sine x equal to 2 secant x tangent x. So what we have to do is make the denominator equal so that we can proceed with subtraction on the numerator. So that means that we should multiply 1 minus sine x and 1 plus sine x. For the first fraction, we will get 1 plus sine x because 1 minus sine x will be cancelled. For the second one, we will get 1 minus sine x because 1 plus sine x will be cancelled. So if we simplify this, that becomes 1 plus sine x minus 1 plus sine x all over. So using the FOIL method for the denominator, we will get 1 plus sine x minus sine squared x. And then sine x minus sine x zeroes out. On the numerator, 1 minus 1 zeroes out. So to simplify that, sine x plus sine x is 2 sine x, and then 1 minus sine squared x is our denominator. Now, using the Pythagorean identity cosine squared x plus sine squared x equal to 1, subtracting sine squared x to both sides of the equation, we can get that cosine squared x is equal to 1 minus sine squared x. So that means that we can replace 1 minus sine squared x on our denominator. So that leaves us with 2 sine x all over cosine squared x. If we try to factor cosine squared x in the denominator, we will get sine x over cosine x and then 1 over cosine x. So we know that 1 over cosine x is equal to secant x. And then tangent x is equal to sine x over cosine x because of the quotient identity. That means that our answer is 2 tangent x secant x, and that's what we're trying to prove. So now we prove that this function is equal to 2 secant x tangent x.